With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Question is a uniform ladder of length 3.25 meter and weight 250 Newton is placed against a smooth vertical wall with its lower end 1.25 meter from the wall. If coefficient of friction between the ladder and floor is 0.3, then find the frictional force acting on the ladder at the point of contact between the ladder and the floor. So here we can say, suppose the wall is smooth and here the floor is rough and there is a ladder. So this is our, let's say, ladder here. This is our ladder given in the question. Now this is resting against, let's say, this smooth wall, and between the floor. Coefficient of friction is given here as 0.3 between floor and the ladder. So here length is given to be of 3.25 and the weight here acting, let's say, along downward direction of this ladder is 250, we can say, as Newton. So here the lower end is 1.25 meter from the wall. It is being said that this distance is 1.25 meter and this rod length is given here as in the question, let's say, 3.25 meter. So this here is our 1.25 meter and this here is our, let's say, 3.25, we can say, as meter. Now we need to find the frictional force acting here. So we can see that here when this, let's say, point comes downward, that is, we name this point as A and this point as B. So A point comes downward, hence B point will move, let's say, towards left. So friction will act towards right. We need to find this friction. Now the forces we can say here acting will be drawn here as, let's say, normal reaction NB, let's say, upwards, and we can see here normal reaction NA towards the, we can say here, left direction. So here this here is our normal reaction, we can say, as NA, and this here is our normal reaction, we can say, as NB. So these are the three forces, NA, NB and F, and F here can be written here as mu into, we can say, as NB. So first we can find, let's say, here along the vertical direction the force is, let's say, NB, and in, let's say, downward direction we have here as 250 Newton. So NB comes as 250 Newton. So here in the horizontal direction we can see here this NA will be equal to our friction force. We need to find this friction force, and the limiting friction we can say here is equal to mu into, we have here as NB. So this comes out here as mu we have here as 0.3 and NB we have here as 250. So this comes out to be 75 Newton. Now we need to check whether this whole, let's say, 75 Newton acts or not. Now if we, let's say, apply rotational equilibrium about point B, so about B, let's say, we, let's say, can say here that net torque is 0. So net torque we can say here of this, let's say, 250 Newton will be equal to as 250 into this distance. Let's say here this perpendicular distance can be said as, if this here is our theta, so we can see here the 250 Newton, let's say, acts along, let's say, L by 2 of, we have here perpendicular distance of this 250 Newton, as total rod of length is 3.25 meters. So L by 2 into, we can say here as cos of theta is equal to, now here in case of NA, here this NA, let's say, force is along, let's say, left direction. So the perpendicular distance will be here as L of, we have here as sine of theta. So L and L cancels out, hence this comes out here as our, let's say, we can say, as 125 into here this is our as NA into, we can say, sine by cos is our tan of theta. So we can say 125 is equal to, we have here as Na into tan theta will be this perpendicular by base, where base we have here as 1.25 and perpendicular distance can be written here as, let's say, we can see this perpendicular distance is square root of this perpendicular distance as square root of, we have here as 3.25, let's say, square minus of, we can say here as 1.25 whole square. So this here comes to be our on calculation as 3. So 3 meter, we can say this here is our 3 meter. Hence we can see here the normal reaction A here to be our 52 point, we can say as 1 Newton. So this 52.1 Newton is the corresponding frictional force. So we have the frictional force as 52.1 Newton, which is our answer.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.